Okay, while we're talking about different types of function notation, we are going to jump to 10.1 and talk about composition of functions. More function notation. Okay, so let's look at an example of where g of x is given as 2x squared over x minus 1, and f of x is given as x squared minus 1. And you will be asked to compose these functions. So something that they may ask you to do is to find g of f of x. G of f of x. Or you may see it written as g of f of x. Those two notations mean the same thing. And we're used to substituting in numbers like g of 4 and find a result. But in this case, we're substituting in an expression or another function. So what is f of x? Well, f of x is x squared minus 1. So in reality, it's asking us to find g of x squared minus 1. Well, how do we do that? Well, again, this is our input. This is our input. This is our replacement for every x in g. It's our replacement. So let's go ahead and replace that. Replace this x and replace this x with our input. So it's going to be 2 times x squared minus 1 squared all over x squared minus 1, again, replacement with our input, minus 1. Okay? So that's your answer. Now let's just simplify it. To square a binomial, you have to FOIL the two binomials together, or you can remember how to square a binomial using the binomial square theorem or Pascal's triangle, which is what I would do. It's going to save you time if you know this in the future. So to square a binomial, it's the first term squared, the first term times the second term times 2, and then the second one squared. And on the bottom, we have x squared minus 1 minus 1. So your final answer is 2x to the 4th minus 4x squared plus 2 all over x squared minus 2. Okay? Now, let's take a look at something a little bit different. Let's take a look at an example where they say, given that f of x equals x squared minus 1, and this should look familiar to you, find f of x plus h minus f of x all over h. Remember that? I'm going to practice that some more because that comes up in calculus all the time. Okay, so this is f of x plus h, and this is f of x. So the question is, how do you find f of x plus h? Well, again, this is our input. This is our input into f. It's our replacement into f for every x. So let's go ahead and do that. We're replacing our x with our input, x plus h. Okay, so that is f of x plus h. That's just this first piece here. Then we need to subtract the f of x. As I've said before, let's simplify this first. Again, squaring a binomial. The first term squared, the first times the second times 2. And then the second one squared. So we've done this before, just to do more practice. So let's now find the original f of x plus h minus f of x all over h. So this is our f of x plus h. I figured out that piece first and simplified it. X squared plus 2xh plus h squared minus 1. There's our f of x plus h. Minus our f of x. Well, what's our f of x? Our f of x is given. And you have to subtract the quantity, otherwise you're going to get the wrong answer if you don't use parentheses. And then all divided by h. Okay, so that's going to give you x squared minus x squared, which is 0. And then you're going to have 2xh minus no 2xh's. And then plus h squared minus nothing. And then a negative 1 minus a negative 1 is the same thing as a negative 1 plus 1, which is 0. And that's all divided by h. Now, if you recall, each term has an h in it, so you can cancel out an h out of each. Or, to show your work properly, factor out an h out of each term. And now you can cancel the h's, and your final answer is 2x plus h. So that's practicing the difference quotient. Okay, understanding function notation. That's what we've been doing the last couple of sections. Okay, now another way that they need you to understand function notation, I'm on 3, is what if I give you f of x as a composite function? I'm giving it to you composed already. And I am going to tell you that this is the composition of u of v of x. So I'm telling you that you inputted v of x into u. You replaced v of x for every x that was in u. So can you think backwards and try to figure out what v of x is and what u of x would have to be? If this is the composition, what did you plug in? What did you substitute in? Your substitution. Well, looking at this, I substituted in, this is my inside, I substitute in x cubed plus 1. And what was the function that I substituted or replaced all of this with each x? What would have been the original equation with the x in it? Well, if I substituted all of this in for x and I replaced an x, then my original function must have been x squared. And that's called decomposing. That's the opposite of composition, decomposing. So I think we need to try a couple more. Okay. Example number 4. Let's say h of x is equal to, let's go with 11x squared plus 12x, the quantity squared. And let me tell you that that composition came about by composing f of g of x. Okay? F of g of x is 11x squared plus 12x, the quantity squared. What is your input? So I would say 11x squared plus 12x was my input. I replaced that with all x of what function? Well, again, my outer function, I plugged in all of this into f. So f of x must have been x squared. Okay, so that's just like that one. Let's try ones that are a little bit different. Let's say h of x was your composition, and your end result was x squared plus 2. 1 over x squared plus 2. Okay. And that was the composition of f of g of x. So this is f of g of x. Our composition resulted in this. See if you can figure that one out. You can stop the video and give it a try. Okay, the one thing you cannot say is I plugged x into 1 over x squared plus 2. Okay, that would be useless. I could say that for every single problem. So you can't use that. So what could have been my substitution? Well, my substitution, my replacement could have been x squared plus 2. That means that I replaced x squared plus 2 for every x in my f function. So if I replaced my x with this, what was the original function? What was f of x? This is your substitution into the original. This is the composition. I substituted x squared plus 2 into 1 over x. Okay? Decomposing. All right, one more. Let's say that our composition, our end result, was x minus 2, the quantity squared, plus 1, all over 5 minus x minus 2, the quantity squared. Okay, and that was a result of f of g of x. Or again, notation, f of g of x. That's another notation for composition. When you see it like this, it's you're plugging g of x into f. You're plugging g of x into f. So looking at this as our end result, what do you think g of x is? What do you think you substituted into the original? Well, really, sometimes there's two possibilities. So the first one I'm going to go with is I substituted in all of this. I substituted in x minus 2 squared into x plus 1 over 5 minus x. if I substitute all of this in for x, I get this. If I substitute all of this in for x, I get this. So that's one possibility. Can you see another possibility? How about if my substitution was just x minus 2? How about my replacement was just x minus 2? Go ahead and figure out what equation you would have substituted, what function would you have substituted x minus 2 into to get that? This is your replacement for x. So thinking backwards. If this was my replacement for x, then it should be x squared plus 1 over 5 minus x squared. So there's two options for this one. Sometimes there are multiple decompositions. Depends on what you see. Again, you cannot say I plugged in x. That is not an answer that you can give for the decompositions.